Okay, today I'm going to talk to you about alkali metals. So if I was to look at the periodic table, we can see that the alkali metals are here in group 1 of the periodic table, so on the left hand side of the periodic table. I've actually written them down here so we can see them nice and clearly. They are lithium, sodium, potassium, rubidium, cesium and francium. So because they're in group 1 of the periodic table, the key bit of information we need to know is they have one electron in the outer shell. Because they all have one electron in the outer shell, it means they all have similar chemical properties. And there's another video that will show about how alkali metals react. Compared to other metals, they have lower melting and boiling points. So slightly different physical properties. So they're not like a lot of other metals. Another reason why they're not like a lot of other metals is they're very soft. You can actually cut them with a knife, which is very, very peculiar compared to lots of the other metals on the periodic table. So let's have a little look at the reactivity as we go down the group. The least reactive is lithium at the very top of group 1. As you go down the group, each alkali metal becomes more and more reactive. The most reactive one is francium down at the bottom, which is extremely, extremely reactive. So we need to know, why is it that as you go down the group, reactivity increases? So what we're going to do is we're just going to have a look at the difference just between lithium and sodium. Lithium is less reactive than sodium. So if I look at the atomic number here, I can see that lithium has 3 electrons. So I'm just going to draw it here. So there's 2 electrons in the first shell and 1 electron in the outer shell. So here is lithium. Now lithium is the least reactive of all of the alkali metals. And here's why. In order to form an ion, because all of these alkali metals are only involved in ionic compounds and not covalent compounds, so they need to lose an electron. So that electron needs to be lost and given to another atom. So in order to do that, let's just have a think about what needs to happen. Now, these electrons have a negative charge. So electrons, remember, they are negative. So in order to draw this away, basically this needs to be pulled, kind of completely attracted away from the atom. Now remember, in the nucleus of an atom, we have protons. So in the nucleus, this is where we have our positive protons. Now, I'll introduce you to a new term here, which is atomic radius. Now, the atomic radius is the distance from the center of the atom to the outer electron. Because lithium isn't a particularly big atom, there is a small atomic radius, which means there's quite a strong attraction between the nucleus and this outer electron. Therefore, it's not particularly easy for this electron to be lost. So this is what's happening when lithium forms an ion. It starts off as an atom, then we form a lithium ion, and we have an electron. So let's have a look at this compared to sodium, which is slightly more reactive than lithium. So if I look at the atomic number here, I can see that it has 11 electrons. So I'll just draw this quickly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So this here is sodium. Now, because it has 1 electron in the outer shell, it too is looking to lose an electron in order to form an ion like this. So again, it starts as an atom and it has now formed an ion. Let's have a look at the difference in atomic radius. Remember, atomic radius is the distance from the centre part of the atom to the outer electron. The atomic radius is much bigger in sodium compared to lithium. So therefore, there's a smaller attraction between the positive protons in the nucleus and this negative electron. Therefore, it's easier for this electron to be lost. And remember, as you go down the group, that atomic radius is going to get bigger and bigger and bigger. So it's become easier and easier and easier to lose that electron. Therefore, the bottom ones are much, much more reactive. So this is why these alkali metals form parts of ionic compounds, because they lose that outer electron. Thank you.